Okay, I want to do a video on HTTP. What does HTTP stand for? This should be an easy question. Hypertext Transfer Protocol. What does HTML stand for? Hypertext Markup Language. It's easy to get the two confused. HTML is the language that you write the page in. HTTP is moving the pages from one place to another. So to start off with, let's talk about what a protocol is. In the vaguest sense, a protocol is just a set of rules for communication. So you can stretch that out to the Goldie Hawn movie, where you have protocol advisors in the government that say, okay, when you go to this other country, don't hug people. If you go to Japan, you don't tip people. It's an insult. Who would have known it? The same sort of thing, you have rules for communication, except there has to be lots and lots and lots and lots of them. From what's the voltage supposed to be on the wire? How are you going to talk? Lots of protocols. I'm going to hit these two together. There are two main types of protocols that we use a lot: TCP and UDP. TCP and UDP, two different kinds of protocols. One's called connection-based, and one is connection-less. Now, there's a lot to digging into the guts of these. We're just going to kind of skim the surface. TCP is going to track stuff, and UDP is not going to track stuff. TCP, some types of information, you need to have every last little bit of it for it to mean something. If you send a picture or an MP3 across the internet and you drop 3 or 4 packets, is it important to pick those back up again? Yeah, it's not going to work. It may not even display or play or whatever. If you don't have every single bit and every single one of them right, it's going to be lost. Other types of information, it's not such a big deal. If you're watching a video, or if you have some kind of a telephone conversation, VoIP. Some other things, if you drop a few packets, it's more important that you catch up and just let the loose end drag and just keep going. TCP will actually build a connection. It does what's called a three-way handshake to say, I'm going to talk to you. Can you talk to me? Can you hear me? And when you send packets, it's continually going to say, did you get that? Did you get that? I just sent you number 45. Did you get it? And it's going to, the receiver is going to be sending information back saying, yes, I got that. UDP, on the other hand, is just going to say, I'm going to blare this out. You listen. If you don't hear it, just holler back at me. In the classroom, we could use that. I could say, every one of you, did you hear me, Paul? Did you hear me? Did you hear me? Every few sentences, and I would know beyond a shadow of a doubt that you got every single thing. We use the UDP model. I'll just talk, and if you can't hear me, you just holler back and say, I didn't get that. So that's basically the difference between the two protocols. These aren't protocols in themselves, but other protocols are going to use them or sit on top of them. One of them being DNS. You've probably heard of it before. Domain name resolution. Domain name service. Domain name service server. Uses UDP generally, and it resolves names to IP addresses. You can't remember all the IP addresses out in the world. Too many of them. It's a pain. But you can remember yahoo.com. You can remember amazon.com. Problem is, you can't connect to amazon.com. You have to connect to an IP address. In my telephone, I've got lots of names. I don't remember the numbers. I can remember so-and-so's name, so I don't have to remember the number. I just highlight to it. The phone itself is going to resolve, okay, when he hits this name, dial this number. But you can't put a name into a telephone. You have to have a number into the telephone. Same sort of thing with DNS. And it uses UDP. If it's quicker, that's one good thing about UDP over TCP, but it might have to re-request some stuff. There's our guy, HTTP, Hypertext Transfer Protocol. Uses port 80 by default, and it's defined in RFC 2616. Let me pause here for just a second as I go over that. Okay, what I did was I looked up RFC 2616, and there it is. RFC stands for Request for Comments. Some protocols are owned entirely by a company. Lewis's favorite, EIGRP, is owned by Cisco. So if they want to make changes in it, Cisco does it. And they say, we have made changes, accept it, deal with it. Other protocols, the more popular protocols, use what's called a request for comments. They publish these RFCs out on the internet, and what it is here is all the information about it. It's owned by everybody. It's a standard everybody uses. Nobody owns it. So if I come up with some fantastic idea that I want to add to it, they have requested my comments. I can publish my comments or my ideas, and then they would be published to a bunch of people that are concerned with this, and together they can decide what direction they want to take with the protocol. So that takes the ownership away from a single company or person. And RFC 2616 defines the HTTP protocol. You've seen the dreaded 404 file not found? That's defined in that RFC. A 200 means it was good. That's defined. So everything about it is defined in that. I'm not saying it's easy to read. I'm just saying it's there. FTP, file transfer protocol, uses TCP. It's got a little brother called TFTP, trivial FTP, that uses UDP. But people are going to want to publish web pages. They're going to want to get them up to you some way or another. That's what you'd use. You'd use FTP. I don't have it on here, but what ports does FTP use? 20 and 21. It uses one to send information back and forth, and then it uses the other to send the actual information back and forth. So that's FTP. Kind of out of protocols here now. An IP address. IP address, a 4-byte address. That's a byte, that's a byte, that's a byte, that's a byte. Each one of those has to be less than 255 because you can only count to 255 in one byte. 8 ones in binary is 255. It's a logical address for a computer or a server. It's not burned in anywhere like a MAC address is. You can set it. You can retrieve it from somebody else. You can set it to something else. Every device must have one. No two devices can have the same. A port number. Port in French, that means a door, or a porthole on a ship. It's a hole in something, right? A porthole on a ship is a place for things to come in or things to go out, or a door. Think of ports as doors on your computer. You have an IP address, that would be the address of your building, and then port numbers would be the external doors that you could get in through. So just to secure a server, you would want to lock up all your doors except the ones you absolutely had to have. If you had a building with lots and lots of open doors, you would have a very insecure building. So port numbers are some number between 0 and 65535. The first 1023 are well known. You can't monkey with those too much. Port 80 is well known. 20 and 21 are well known. There's some registered ones, 1024 by 49151. Those are kind of well known, we'll say. They will probably be used by some application. And then dynamic ones, if you're going to communicate, you have to have an IP address and a port number. So if I am the requesting station, I have to have a port number too to leave. I have to have a door in my house for me to be able to get out of it. So the door I'm using to get out of my client or house has one of these high numbers. And then the popular one is 80 when you want to go to a website. A socket is a combination of an IP address and a port, usually separated by a colon. 192.168.254.154:80. That would be your socket. HTTP protocol. We're going to move a web page. There I am at my client. I have an IP address. The port will be assigned when I actually try to communicate. I've already got it thrown in there. And I want to go to yahoo.com. What I just said, I type in yahoo.com, but what really has to happen is something's got to resolve that to an IP address. I could skip ahead if I knew what Yahoo's IP address was and just type that into the title bar and it would go. And that's cool. I don't know what it is. It could change. Some IP addresses actually change. So, before I go to yahoo.com, I've got to ask somebody what its IP address is. Who am I going to ask? DNS. So abandon Yahoo for a second. I want to say, go to my DNS. Where is my DNS defined? Well, if I do an ipconfig/all in Windows, it doesn't give it to you unless you say /all. But notice this right here, DNS servers. It's got some servers listed for me. Servers. DNS is normally so important that you need to have several of them going. Sometimes you'll have 4 or 5 DNS servers, because if you don't, you're not going to be able to go anywhere normally. So that's where your preferred DNS servers are listed. So I have found out what my preferred DNS server is, 207.498.20, 207.498.20. So now I'm going to issue a request out of this guy using UDP, port 53, another commonly known port, and say, you know what the IP address for yahoo.com is? And we're going to assume that this guy has it cached, because we're going to keep things simple today. And it's going to say, yeah, yahoo.com is this. 69.147, that doesn't look like a private IP address, that looks like a real IP address, so that looks cool. So now I can go back to where I started, and I can say, aha, now I know what yahoo.com is. The user, he doesn't care. There's no point in showing him, hey, I found out what this IP address. Just let him see the yahoo.com up in the title bar and be happy with it. So the client now knows what IP address to go to and what port number. By default, it's always going to be port 80. Unless you put a colon and some other number in the title bar, you're just going to assume 80. Now my client can say, get me a web page, and the web server can say, here you go. Is HTML encrypted by default or anything fancy? It is not. So that is why you should be careful when you go sticking your credit card number into one. Anybody with a packet sniffer can sit there and say, hey, look, plain text. I'll just sit here and read it. Doesn't take a lot of skill. Going to back up another step. When I got the HTTP, the web page in the last example, I did what's called a 3-way handshake. And we'll look at this in just a second. But there's that socket. There's that socket. Notice the 192.168, that's a private address. I'm going through a router that's going to translate that for me, but subject for another day. You have the SYN-ACK. That's your 3-way handshake. So the client is going to say, hey, are you there? Here's your number. Just to prove that you can hear me, add 1 to that number and send it back. And the server says, yeah, I hear you. Here, I'll take that 23 and I'll give you a 24. By the way, here's you a SYN of my own, synchronize. And I'm going to give you a 95. So if you can hear me, add 1 to it and send it back. The client says, sounds like things are good. Here's 96. And they send it back. So SYN, and these are just flags. That's a single bit in the header of a packet. Says synchronize, and then synchronize, acknowledge, and then synchronize, acknowledge, and sequences. So basically what those two guys have done, they've yelled at each other and said, are you there? And they both responded and said, yeah, I'm here. It looks like we've got a pretty good way to communicate. And then we can carry on. So this actually has built a connection. These sequence numbers are great big numbers. I've way oversimplified them, making them small. Since they've proven that they can talk to each other, now they can build sequence numbers for packets. And they can say, okay, I'm going to send you packets 1, 2, 3, 4, and 5. And you're going to say, okay, and say, send me number 6. And then I'll send 6, 7, 8, 9, 10. And then you'll say, okay, send 7. And your whole message can be reassembled at the other end. Usually I give the example of the London Bridge. You know where London Bridge is now? It's in Arizona. Sure enough, you can look it up. They took the old London Bridge, they broke it down stone by stone, shipped it across the ocean, and they put it back together again. And the way they did it, you have a whole bunch of boxes, and you write big numbers on the boxes, and when they get to the other end, they just make sure they've got all the boxes. If they don't receive boxes, they have to stop and say, we're missing dun, 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 dun. Send more boxes, and then they could reassemble something as complicated as the London Bridge. That's the same sort of idea. I did drafting for a lot of years. If you've got a big set of plans, you'll always see 4 of 95 pages, 5 of 95, 6 of 95, so you can know how many pages are there that you're not missing any. I want to do a little bit of a demonstration with Wireshark. Wireshark is a packet sniffer. Now what a packet sniffer is it sits on a network and it just watches stuff. It puts its network card in promiscuous mode. Doesn't that sound racy? What that means is instead of just listening for stuff that's addressed to you, listen to all of it. Eavesdrop. Be nosy. Listen to everything on the wire, just to listen for what you can hear, and then organize it into some kind of way that makes sense. Things to notice. We're going to notice the UDP connection to the DNS server. Well, we might not get that because we're not going to use DNS. Yeah, we can. We can. I'll do it that way. The TCP three-way handshake and the http protocol, the GET, the POST, and the return codes. And we're going to look at the difference between reloading a page and refreshing it. So I'm actually going to hop out to the desktop now. Boop. And close some of this stuff down. You've probably just got it there on the desktop, but Wireshark was originally called Ethereal or Ethereal, and it was created by a guy for a systems tool, and it didn't get to keep the name Ethereal because he changed jobs. That's long and short of it. And I am going to close this browser just to make sure that it has to load stuff. Now, you won't be responsible for this. This is just a demonstration. I'm going to pick my adapter, which is right there. Let me go ahead and start Wireshark or Firefox, just because I like Firefox. I may have started two of them. I'm going to go to www.cnn.com. Now, I've not hit enter yet. I can see packets there. That's a good interface. That's the one it's paying attention to. So I'm going to start, and then I'm going to go to cnn.com, and I'll notice that it brought up a page, and I will immediately say stop. How many packets did I get in that little exchange? 2,716. A lot. Tell you what I want to do. I'm going to do another capture. Since CNN is so complicated, I'm going to do another one. magicalchicken.com. That's me. That's my little server there at the house, and I'm picking it just because it's really simple. Start. I'll say magicalchicken.com. There it is. Now I have 37 packets. I think that'll be a little easier to deal with than the other one. So let's just take a look. Now, I don't expect you to understand all this stuff, and I'd be lying if I said I understood it, all of it. But we can take a look and see some of the stuff that's going on. We have some DNS requests. Let's see what my machine name is. I'm ball 20800. There we go. This actually starts right here. 28 internal.net 2. This is our DNS server. A query for magicalchicken.com. All this is in plain text. There's nothing magical about it. See, right there it is. These are actually the bits that went across the wire. I think that's just way cool. But anyway, it actually asked for magicalchicken.com, and then we should see some kind of response back to me. The pointer, that's the same thing. And it should have the IP address, the return for magicalchicken.com, the response, it gave me how long, answers. Right there. There is the IP address, and I can highlight it. There it is in binary at the bottom. It gave me back my IP address. Anything else to highlight in here? User datagram protocol, as opposed to transport control protocol. That is UDP instead of TCP, like I was saying. All right, so this client then had the stuff it needed to go fetch that page. So now what it does, I'm going from here to magicalchicken.com TCP, and let's see what it's doing. Syn ACK. That's the three-way handshake. Notice I've got transmission control protocol. That's it doing the three-way handshake because I don't want to miss any of that web page. What if it's part of a picture? What if it's some text? What if it's whatever? I want all of it. So that's why I'm using TCP. And you can follow this, the stuff that it actually asks. Hypertext transfer protocol, you can see that it requested, and let's see, I'm getting confused in myself here. It sends what version and everything, and then from magicalchicken.com, what did my web page say? It said, rebuilding the chicken, back up in a few days. It's said that for a while. So I can go back through here from Magical Chicken. It didn't find the favicon. Now one neat thing about this is you can right click and say follow TCP stream. There you go. What's in pink is what my server said. It hit port 80 and it said get favicon, and it didn't find it. It gives me some more information about it. It actually does. My web page is so small. Let's see if we can follow this one. I'm trying to find the one that actually has the we can find the text that's actually in there. Clear. Right there was that going back. There we go. Back up in a day or so, and then I've got a link to a song, Rebuilding the Chicken. That was it. So the thing to get from this is that HTTP is just plain text going back and forth. Makes it real simple. You can also see there's a lot of information going along with it, like the identification of the server, and lots of other stuff. Now, let's do this. I'm going to do a new one and say start, continue without saving. I'm going to go back to my browser and I'm going to say reload to current page. And then I'm going to say shift F5 to reload the current page. I did it twice. When you reload a page, does it always bring back everything? No. If the page hasn't changed, it saves bandwidth by just saying, nothing's changed, just here. So let's see. There is me requesting. Let's follow the stream. I requested it when I just clicked the little icon that said reload. I said, give me magicalchicken.com. Here's the languages I can speak. And here was its response. A 304, 200 means, yeah, everything's good. 404 means not found. It gave me a 304 that says not modified, which says, don't worry with it, nothing's changed. I'm not going to waste bandwidth with this. So if it had been a great big page, that would have been a good bandwidth saving. But further on down, I held down the shift key and then hit reload. Did I clear that? I did. I should have. Yeah. Somehow or another, I didn't actually get it. When you hold down the shift key, it actually will do a complete reload of the page. And sometimes we have trouble with that with students. I did that just a few minutes ago, actually. I hit this page, enter. That should have just given me a regular refresh. But if I say shift F5 or shift reload, yeah, that took a second longer. Let's see if that did better. The wheels have fallen off my thing. There we go. HTTP turns out green, so that's cool. There we go. Rebuilding the chicken. And we could dig into this to see the request. There we go. Cache control. No cache. It said, yeah, don't give me that stuff about it's not changed. Completely reload the thing. And what I was saying is we got into this a few minutes ago when somebody, I said, here's your web page. And I said, well, put me a web page on there. And she said, I did. And I said, no, you didn't. And if I just said refresh, it didn't change. But when I said refresh with no cache, I did a Shift F5, it actually forced the thing, say, don't tell me that it's not changed. I know it's changed. Send me the new one. And it did at that point. That's what the Shift F5 did. So that's one of the things we kind of have to watch for in this class. Toward the beginning of it, I think I thought I had thought I'd done one that, yeah, they were both no cache. Okay, so anyway, long and short of it, that is the difference between cache and no cache. So the protocol, the basics of it aren't that bad. To get into the guts of it, yeah, there's a lot to it, but the basics, we're going to be hitting port 80. It's just a text-based protocol. The server sends back response codes. That's it. All right.